This video would still focus on the proof of the derivative of trigonometric functions for complex numbers. We have here our function equivalent to tangent of z. This is equivalent to the square of secant z, which is also true for the real numbers. In the previous two videos, for the proof of sine and cosine, we're able to use the definition. But allow me to use here the rules of differentiation, which would be easier for us to use here. Because if we're going to use the derivative, the definition of a derivative, we are going to look for functions of z plus delta z, and we'll be using multiple sum formulas, which would actually be longer than using the rules of differentiation. And since the rule of differentiation is already acceptable, we can use it here. Now, what are those rules, by the way? What specific rule? Take note that tangent z is equivalent to the ratio of sine z and cosine z. In short, what we're going to use here is the rule on differentiating a quotient. We know that if we have here, see for example, our quotient is, let's use another value here. Let's say k of x is equivalent to the ratio of m of x and n of x. Its first derivative is the denominator times the derivative of the numerator minus the numerator. Sorry, I think my space is just enough, times the derivative of your denominator over the square of your denominator. Let's use that here as well. Our denominator now is cosine z, and our numerator is sine z. This is the other version for our tangent z, the original function. So our first derivative, okay, is equivalent to the denominator cosine z, the derivative of the numerator. Okay, what is the derivative of sine z? Previously discussed, it's also cosine z. So cosine z minus, we have the numerator sine z. What is the derivative now of our denominator? Our denominator is cosine z. It's actually negative sine z, right? So we have here times negative sine z over the square of your denominator, which is cosine z. Now, this would be equivalent to the product of cosine z is we have the square of cosine z. Negative times negative is plus the square of sine z all over. You have here cosine squared, or allow me to still stick to this one because later on there is an equivalent form of that as well, right? So what is this equivalent to? That is basically 1 over, you have here cosine z, or the square of cosine z. What is, of course, we can rewrite it in this manner. When we take out the square, that's 1 over cosine z squared. And we know that 1 over cosine z is secant z. And when you square that, this is equivalent to the square of secant z, which is our target. This shows that the derivative of tangent z is really the square of secant z. The same with the identity on our real numbers, now true for complex numbers as well. Take note, we use here the rule on differentiating a quotient of a function because this is even shorter than using a definition which would take us a lot of time. You can try that on your own, by the way. Thank you very much for watching.